All right, so it is now 11 o'clock. We'll officially begin this. So first, just wanted to welcome everybody to this webinar and set the stage a little bit. For those of you who have attended other webinars hosted by Aaron Mosier and some of our other people, this is a little different format. This is part of our series where we want to talk about, some of our new capabilities, some of the new technologies we're coming out with, or highlight capabilities that people aren't taking advantage of, some of our lesser known capabilities. So this webinar will only be a half an hour. We're going to keep it pretty high level, talking about these capabilities. If you have further questions after this, certainly you can get a hold of us through our normal support email, or get a hold of your, if you're a current customer, get a hold of your account manager. We talk about it in more detail. So, this is really intended to be a high level, short webinar, and this one's really highlighting what we call our deviation detection capability, which is a fairly new capability we have inside the DataPark product. So we'll keep this to half an hour, and then everyone get back to their day. So another just bit of housekeeping. There is on the right-hand panel a set of questions, or a panel where you can ask questions. So that will be the best way. If you do have a question, type that in, and then we can answer those at the end of the webinar. So today, there will be two people from Capstone joining, myself, Kevin Jones. So I'm the Director of Sales and Marketing. I've been with the company almost 19 years now, and I'm mainly the one that's going to kick this off and kind of facilitate it, and then I'll hand it over to Ron to do the real heavy lifting. So I'll let Ron take a moment and introduce himself.
Yes, I'm Ron. I'm Chief Technical Officer for Capstone. I've been with the company since the beginning, since it was founded. So what we'll talk about today is pretty near and dear to me because we've been after this for quite a while.
Okay, perfect. And then just another note for those of you who may not be fully familiar with DataPark. What we're going to talk about today is part of our fully integrated solution. So we're talking about, real kind of narrow use of deviation detection, but the data that we'll be talking about can come from anywhere. So one of the kind of the core aspects of DataPark is the ability to bring data from multiple sources and provide one place to view, analyze, and make decisions from that. So this capability we're talking about is no different than that. No matter what historian, lab quality, MES system you have, no matter where that data exists, we can make that available through this deviation detection capability. So that's really the last slide that I had. At this point, Ron, I'm going to hand it off to you, make you the presenter, and let you get started with the interesting parts.
Can you see my screen?
We got you. It's all yours.
Okay, great, thanks. What you'll see today is we've had all these pieces for several years, some of them for many years. What we're trying to do is put many pieces into one for ease of use, and that's the goal today, is to show you how we've done that and how we use the tool. So we do a lot of process engineering work for customers. We're SMEs, subject matter experts in cases, and these are tools we really needed all along. One of the problems we have with industry, any processes, is that they tend to drift over time, and we have controllers out there that try to keep them on track, but eventually the process drifts too far. We have issues, one of generally 5: production, quality, environmental, cost, or safety. One of those will bite us, and then the question comes from management is, what changed? It's always, of course, they'd like to have the answer, what do we need to go do to fix it? But the fundamental part is, what changed to put us in this situation? And it's usually either physical equipment, maintenance that's been done on the operation, or the way we're operating the equipment, the operations itself. So one or the other, and our goal is to try to get after the operations section of it. And who's asked this question, what's changed? anybody who's in the room, anybody who's associated with the problem, operators, process engineers, control engineers, maintenance engineers, managers, anybody who's there that can field the question they're asked. And when are they asked? Day, night, weekend, it doesn't make any difference. It's when there's a problem, everybody's sort of on call. So what we need, what we're after, is we need to quickly identify what's changed. We need a go-to tool for everyone, one that everybody's familiar with, looks the same, and gives quality answers to them. We want to know if the value's changed, if it's gone up or down, and what the variability is. Has the variability changed? Those are the two primary things we're after. And the tool has to be easy to use, or people won't use it. They don't have time. Particularly if we're trying to use it in a proactive mode, where we'd like people to take a look at the tool before the problem happens, because people just don't have time these days. So when we talk about deviation, we're going to talk about 4 particular types today. And like I said, you've seen these in our tools at one point throughout the years or another, but we're kind of combining them into one. First is the simplest, percent change. We take a base period where things are running well, we get the average, and then when we look into the future and something's wrong, we want to know how much it's changed from the average. That's the simplest one. Variability. We want to know, has the variability changed in some way? And in this case, we'll show the COV change between a good period and a bad period. And COV is basically a way to take variation and normalize it based on the value. So high values don't necessarily get a higher standard deviation than low values because they're normalized by the value. And then standard deviation, anybody who's done control charts in the last 30 years, this is after that kind of change. You take a period of data, you get the average, calculate the standard deviation, and put limits up. Plus or minus 3 standard deviations is pretty typical. And then you evaluate where you're at based on that, whether you're out of normal or not. And then one that's been around the last 5, 10 years is more advanced modeling, and we call it PCA modeling. And that's where you take all the variables, put them together, you model them against each other, and you try to narrow the range. Instead of having flat ranges, they're oftentimes rate dependent is a very typical one. So you want to be able to take rate into consideration. So PCA modeling allows you to narrow the window on that to look for change. So those are the 4 types of variation we're going to talk about. So when we present the tool and the use of the tool, there's 5 steps that you need to make the tool work. The first one is you need to get the tags you want to look at. 3 ways to get the tags. Tag browser, you can search for the tag browser, find a group of tags or a tag, and drag it over onto the deviation detection tool. Or you can take an entire display, which is my favorite. This is perfect because sites where we've gone out and we've provided advanced graphics and trending or center lining, we've got all the key variables in one place on a graphic. So rather than type them in, you can go select that graphic and all those tags get added automatically. That's the best way. But you can also, if you've configured all your process tags in a process unit, in our configuration, you can select the process unit that those tags are in, and it'll drag all the process unit tags in. And you can use combination of these, any to get the list of tags. The next thing that's really critical is that you select a downtime tag, or it can be more than one tag. And that's where you pick that tag and you say, within this range, I'm operating, and outside this range, I'm not operating. And that helps because then you can go pick broad amounts of data. You don't have to worry about going in and filtering out the data by hand. That'll be taken care of for you. The third thing you need to do is select a good period of data. Find a place everybody thinks that's a good amount of operation. A week, 2 weeks, what for your process, whatever makes sense. And from that good data, if one of the items you want to do is a PCA model, you can build within this application the PCA model. Now you've got the base built. Now we need to find a bad period. Either we wait for a bad period or we proactively look as time goes on. So the two cases of good data and bad data I'm going to show you for this process are in April and May for the good period, and around the middle of July for when the operation wasn't running very well. And once we get those two periods of data, we're going to take a look at the deviation types and see if we can figure out what's wrong. So I'm going to skip steps 1, 2, 3, and 4, putting the tags in, getting the downtime tag. Those are pretty rote kind of operations. And when you end up, this is the final display you get. On the left-hand side is a list of all the tags that you've selected. To the left of the gray bar is the base time, or the good period. 4:15 to 5:15 is the date I said I was going to pick. And it gives you the average and standard deviation during that period with the downtime filtered out. Then we pick the time we want to go look at that we think is not operating very well or operating poorly. In this case, we took 7:19 to 7:20, which says it's going to be in the middle of July, and we get that average and standard deviation. Now we're going to look at the data 4 different ways. They're the yellow columns here. The column I use mostly is standard deviation change. That's like the control charting. How many standard deviations am I away from the average? And that's the one that's selected here. And the way you use the tool is you click the column you'd like to sort on. So I'm going to click the percent change column. Oh, I see. I'm going to go into that now. So that's the way it's going to work. I'm going to give you that actual demo of that and bring up the application. So we have the standard deviation select column selected here. I'm going to go ahead and blow it up full screen. If I pick the percent deviation change column, it sorts by the maximum change to the minimum change. And it sorts whether it's positive or negative, it sorts by the absolute value. Pink numbers mean it's higher than the base period. Blue numbers mean it's lower than the base period by that percent. So if I go back to standard deviation change, you'll see that it's sorted by the number of standard deviations it is away. So that's 9 standard deviations away for the bad period. If you sort on the D mod X column, that's the PCA, it does the same thing. Each time it gives you a different list of tags according to what it thinks changed the most. And over on the right-hand side, depending on the column you look at, depending on how many days you've looked back in the past, it'll show you in reverse order, 7, 19, 18, 17, what the readings were the previous days. So if you can see if there are changes taking place at that time. And something I didn't mention earlier over on the left is it's really important to be able to rank these tags. We can't just throw them all in the bucket together. Some are truly more important than others, and some are meaningless. So we just do it alphabetically. I gave 2 tags an A. One is the tag that I sort for uptime on, whether it's running or stopped. And the other one gives me a rough idea of the production rate, which is the steam flow. I want those to be at the top because I always want to be able to see them. And then I have my sort of second level tier being Bs and Cs and so on beyond that. So you can decide, depending on your base data, which type. If you've got a good PCA model, you might look at D mod X, or you might look at the standard deviation change. So that's the way once the tool is set up, you just pick the date you want and then go look at the deviations that you think are important. So with the tool, the goal then is to fill out the comments column over here so that we can, the tags that we know we think there's something wrong with and we understand what it is and whether it's a problem or not, we try to select those out. For instance, we have one here that's the cooling water temperature, and we think it's seasonal. So with this tool, you can pick that tag or any number of tags, and go up and click the trend bar, and it will bring up the base period that you calibrated against for that tag, and we can see it's 30 days here, and then the current period that we're comparing against on the right. So you can say this tag is higher, but we're only looking at one day here. And what we'd really like to do, just invariably, every time I bring this up, is I'd like to be able to see the time back to when we calibrated it for the good period to see what changed. So we've picked 100 days. That gets us back to the period when we had the good data. And that's shown in the red box here. That's about the first 30 days of this trend is the data period in the base period that we chose. And you can see that it's gradually going up over time. And we think it's seasonal. And since this is cooling water temperature, we go and find the tag in the tag browser for the river water temperature just to see what it looks like in comparison. And sure enough, they roughly go off together. So we know that tag, the cooling water temperature, isn't caused by anything other than a seasonal variation. So for that reason, we'll go in and put notes down. So you can say that change is seasonal, another change is seasonal. The result tag is where we say a particular tag that's showing deviation, it's changed because we have the problem. So it's not the cause of the problem. And here you've got to understand the process and use your knowledge, but that's generally pretty straightforward. And what you get down to then is there will be a tag that you have no reason why it's that way, and it should not be that way. And in this one, it's about the 5th tag, and this is a extraction train, a multi-stage operation, and the 6th section of the train is the one that's having a problem. The driving force, that's the delta T, has gone up from 26 to 45, or about 69% it's increased, 6 standard deviations. And it's interesting that the D mod X and the standard deviation change and the percent change all show that value to be high. And so that's something that gets stacked against it, is when you say multiple indications of variation all say that you're the problem. So now we can focus on, we had in this list of tags that we chose, we had 363 tags, and we immediately got down to about half a dozen. And by being able to trend off of this display and mix it with tags from any source, we can narrow it down to the one that we think's the issue pretty quick. Especially this works well if it's a morning meeting and you're troubleshooting and there's a group of technical people in there. They can breeze through these pretty quick and yay, nay, and yes, no, and pretty much quickly zero in on the one that they're interested in. So the example I showed you was for a base period in May and then a problem in July. So I decided before I got off of the tool, well, here it's October. I was giving you a demo of how it worked. Let me just look at the current period, the 28th to the 29th. What kind of condition does it say that we're in right now? So put in that time period and it popped up, and you can see it added the 1028 day over here. And all of a sudden, this particular variable, the first one, he's 62 standard deviations away from where he should be. So curious to what that problem is. So I'll run a little movie here and show you the way I took a look at it. So the standard deviation column, the 1028 column, is the one that's high, the 62 and 38. And so we take those two tags, or you can highlight as many tags as you want. You don't have to pick one tag. And then you go hit the trend button that I talked about a little earlier, and it's going to pop up with 2 trends. Now it's bigger than the screen, so I'm going to resize it here so you can see both sides like I showed you a minute ago. And it shows you the 3 tags from the base period on the left, 3 tags from the current period on the right. Now I'm going to double back in time because that was only 1 day. And I go to 16 days on the right-hand side. And I can see the yellow tag, the one that had changed value of 62. Its temperature is 510 degrees, impossible. And sure enough, I was just curious, how long ago did we lose that temperature probe? How long has it been acting up? And it's really recently. It's just been the last couple of days. Now that's a tag that the operators do not use to run by, but it's tremendously important if you're trying to troubleshoot. So this gives us an opportunity to find those tags that are bad before we really need them. Otherwise, nobody looks at these tags. It'd be 2 months or 3 months, and then the tag's worthless because you've got 2 or 3 months of bad data. So it's another example use of the tool. So that was, we gave you an example earlier. It was more being reactive to problems that occur. The one we just showed you is a little more being proactive because we find a tag before we're even into a problem necessarily that we're looking at. Another tool that we're going to give you a couple examples of more current tools that we are developing and putting out. In the top right is a list of the attributes that you can monitor for the list of tags. It's great. We wanted this for years because I can go look at one or I can go look at another. It just takes a lot of time, but I can stack these up next to each other, just browse between them to see what they say. One of them is frequency, period, tag. What's the oscillation frequency, if there is one for the tag? So I applied it against this same exact problem. And it then, since it's picked the button, it organizes in the slowest frequency to the highest frequency and orders them together. Well, that's great because then I can take the 2 tags here. Oh, both those are 0.6 minutes frequency. And then I can pull up the trend like I showed a minute ago and do an FFT. For anybody who's used our trends, you can go to any trend and right click and say do an FFT, and it'll do an FFT of all the tags on that trend. So I trended these 2 tags and did an FFT on it, and sure enough, it nailed it right on the money that there's a 0.6 minute oscillation, and those 2 tags are stacked on top of each other. Of course, they're from the same point in the process, so that's not surprising. But without this tool, if I want to go see if any tags are at the same frequency or what the frequency of most of the tags, I'd have to go pull each one up in the trend or put them all on one trend and go through them almost individually to be able to find it. And here, 363 tags up here on this particular list, and they're all lined up on the right-hand side. I don't have to go find anything. I can line them up and then trend the tags that are similar to each other. So the goal is this top list up here on the right is that we make those available to any one of these displays. You could turn them all on if you wish. Of course, the top ones go fast because they're simple, and the bottom ones in the list tend to go a lot slower because the processing takes a little longer. But the value that you get out from it is really great for us on the process engineering side and the troubleshooting side. Another piece of the puzzle is I would really rather not have anybody go in and use our tool directly. Another thing that can be provided is a report every day that takes the list of tags and says, I'm going to show you, this is a little small to see, I understand, but the yellows are highlighted, and it gives this single sheet report that says, I'm going to show you the 15 tags that are the highest percent change in a list. And then I'm going to show you another 15 tags in order of the ones that have the most COV change. Same way with the standard deviation and the D mod X. So they could be the same tag. The 15 could be duplicated in each one, but they aren't. Generally, there will be 4 or 5 that are duplicated in each one. But with this kind of a report, nobody even needs to use the tool we're just discussing unless it needs to be altered in some way. They could just pull up this daily report when they're interested and scan over to the right-hand side and first of all, see which tags have changed the most. But one way I look at it is like down here on the right-hand side, I like to see those things that have all of a sudden changed. For instance, this one, but I'm not sure you could read it, but it's -7, -8, 4, 43. Well, those are significant. I should probably look at those because those changed between yesterday and today. So this kind of report could be used by anybody, operators, managers, as a quick take a look to see if they need to pay attention to anything. So in summary, where we're at with the tool is it's a great tool for quick identification of changes. I mean, once it's set up, you can be in and out really quick. The surprise to me was I was actually the percent change column, the really kind of crudest one, I thought we'd probably never use it and we ought to just leave it off but by default. But it's turned out for short duration periods, people use it a lot ad hoc. I go, it was running great at 2 o'clock yesterday afternoon, and now it's not. They want to look at 1 hour there and 1 hour now, and that's just a quick and dirty way. So that was a surprise to me. The bonus is that we can proactively identify bad tags. Normally, we're not necessarily looking for that. We're looking for process changes, but this is perfect because those bad tags can pop out really quick and we can get them fixed. The tags that are normally not used for direct operation, but later for troubleshooting. An additional topic we didn't cover today for those who have processes that are product-based or SKU or grade-based, you need to use things called our golden runs in the center line, and this tool can do that too, but that's a detailed enough topic that would be good for another discussion. So our goal for this tool is that from a user's point of view, will be across 5 tiers: operators, process engineer, control engineer, maintenance, and manager. Every tier can pop in and take a look at something and get a feel for whether the change it needs to be looked at. The boundary condition should be, this is the goal, within 5 tags of the problem. Hopefully we can say the top 5 in the list, we're going to find the tag that's going to direct us to where we need to go look. Not necessarily exactly what the problem is, but it'll tell us where to look for that problem. And we need to be able to do it in 5 minutes. We've got it. People will not be proactive at, oh, I'm going to go see if any tags are out, if they got to go out and spend half an hour, 20 minutes, even 15 minutes pulling up that list. It's got to be, my feeling is this day with people so busy in operations that it's got to be within 5 minutes. So that's the goal of the tool as we've presented it today. Questions, Kevin?
That was great, Ron. So just a couple of observations I wanted to point out, or I guess make sure I understood correctly. So it looked like on your screen, you'd set them up for a given process area. So you had 300 and some tags for a given unit operation. Is that kind of how you see this being used, that you'd have several of these data sets for different unit operations?
Yes. At one particular site, we have it for every unit of operation. I think we have 15 unit operations, and then we generate that report every day for each of the 15.
Okay, so they're using it for more the day-to-day proactive decision-making with those automated reports for the unit operations, but they can always drill into a troubleshooting mode also if they need to, like you were showing us.
Yeah.
Good. And then I guess one of the things I think it's always helpful is to get started. Kind of what's the best way for, if someone was new to this, to get started? I think you mentioned earlier about importing from Trends or Tag Browser. Could you just expand on that a little bit?
Yeah, in the early stages, people don't necessarily have the trends or graphics built. And that's usually where people start. And they start with Tag Browser. And in the Tag Browser, sites generally have some key mnemonic in a tag if we're lucky. that the O5 area is the process we're looking at, or the 1.1 area is the process. And the tag browser is great for saying, okay, under the tag name, you type 1.1 and then star.pv or something like that, because the PVs are the really ones you're generally after. And you get, if they're categorizing the plant that way, in a very short time, you can be up. In 15 minutes, you can be up and running with a list of tags to get you a long ways down the road.
Okay, great. Well, I think we're right at 11:30. And just to the audience, a few questions have come in about current customers. How can you get started with it? This is a new capability that we've kind of have, I'd say, in limited release at this point. So what I would suggest is just send a question, or I guess fill in the question field that you're interested, and then we'll have somebody contact you directly. We can talk a little bit about how we can get started with this and get you using it. And for those of you who are new to Data Park, feel free to do the same thing. You can get a hold of us through that question field, or I'm just going to pop back to making myself the presenter. And also feel free to contact us at either our website or through the email below if you're totally new to Data Park. And again, thank you everyone for attending. Ron, thank you for putting together this and showing everybody. It was spectacular. We'll talk to everyone soon.
Thanks. Bye-bye.
Bye-bye.